Hello everyone. Today we are going to start a new lecture series on power systems operation and control. So in this lecture we are going to see what are the topics covered throughout this lecture, that is a course overview. So let us see one by one what are the topics covered in this course. Right. So in the first unit we will be coming across what are load flow studies actually. What is load flow study? That means when the load flows from generation part to the point where it is being consumed, at what stages it undergoes, and what is the importance of learning how the load flows from generation part to the utilization part, right? So in this unit we are going to study what is bus classification, how the buses are being classified. So for that we need to learn how to write a nodal admittance matrix. So that means we are defining what is a node here and writing the node equations. Nothing but mathematical representation of power systems we are learning in this subject, right? So for mathematical representation of load flow, so we need to in the first unit we will be solving a power system mathematically, right? For that we need the help of nodal admittance matrix and how the transmission network is being represented mathematically, right? Also how the Y-bus is formed. So for that there are different methods like direct transformation and singular transformation method. Those methods we'll be studying in this topic, right? So next, how to write load flow equation. The unit is what load flow studies. For that I told you we are studying mathematical power system, right? So how to write equation for that, that is load flow equations. So how to solve it? For solving that there are few methods, iterative methods. Those are like Gauss method, Gauss-Seidel method, Newton-Raphson method, Newton's decoupled method, fast equivalent method, and we'll be studying each of these methods in detail. Also we'll be studying the comparisons, merits and demerits of these methods also. So these are the different methods of solving a load flow equation. That means solving a load flow in a power system, right? We are studying the data, how the load is being flowed in a power system. This is about the unit 1. And coming to unit 2, that is nothing but economic operation of power systems, right? Here economics part, as name tells us, right? So that is how, if a power system has to be run economically, what must be the distribution of load between each unit in a plant. Understood? There will be different units in a certain plant, right? So how the load must be distributed between these plants will be studying in a unit 2. That means to run the unit economically, that means to run the power system economically, how the distribution must be done between the loads, right? So the next topic is transmission loss as a function of plant generation. So when compared to how much generation is being happening, we'll be comparing that with during transmission how much loss is being taken place, right? So that is this topic, transmission loss as a function of plant generation, right? Next one is calculation of loss coefficients. So that means what is a mathematical representation of that loss. Also distribution of load between plants, as the same as topic 1 but mathematical representation. Next one is unit commitment. What is unit commitment and what are the constraints of unit commitment problem we'll be learning in the second unit, right? So coming to unit 3, that is load frequency control. Now how the frequency of the load must be controlled, that is our unit 3. So first of all, what is a load frequency problem, why this problem is occurring, and what are the different methods of control. There are two methods of control, that is PF control and QV control. So what are these control channels? Also what is dynamic interaction between PF and QV loops? What is interaction between? I told you these are the two methods, right? So what is the interaction between these two? How, when these two are occurring? So when these cases arise, that all will be studying, right? Next, mathematical model of speed governing system. So there will be different speed governing systems in a power system. So how to represent them mathematically. Also turbine model division of power system into control areas. So a given turbine model will be split into different control areas, and those will be split into single control area and two area systems. So how to study these two, how to do PF control in these two control areas when when it will be a controlled system and when it is also a uncontrolled system. For both cases we will be learning what is PF control, right? So this is about unit 3. Next, coming to unit 4, that is power system stability. So actually, what are the different stability problems that arises in a power system, that will be learning in the this unit, that is power system stability. What is a stability problem actually? So what is this term steady state stability limit, right? So this we also will be studying control system, but here power systems point of view, what is the steady state stability limit, right? Then how to represent it in ABCD parameters. As I told you, the subject is all about mathematical representation of the issues raised in a power system. So how to represent that steady state stability limit in ABCD parameters, and steady state stability of synchronous machine also will be studying. We'll be studying different terms relating to stability like transient stability and dynamic stability, right? Transient stability, dynamic stability. So there is a term called swing equation, equal area criterion of stability and its applications. So how to write a swing equation, all these steps, how to step by step how to solve this swing equation, what is the application of this swing equation, all these things will be studying in this power system stability. So this is all about unit 4. Now coming to the last unit, that is unit 5, reactive power voltage control, that is QV control. So what is actually reactive power control, that will be studying in this unit. Also excitation systems. So how these excitation systems are being handled and modeling of the systems, and their static and dynamic analysis, and if there is any stability problem, how to compensate the stability problem, and generation and absorption of reactive power, how this generation and absorption of reactive power is being taken place in a power system. Also the relation between voltage, power and reactive power at a particular node, that will be studying, and how to control the voltage, methods of voltage control, that is by using a tap changing transformer. Also system level control using generator voltage magnitude setting. So this will be studying how this level control is being done. Also tap setting of OLTC transformer and MVR injection of switched capacitors to maintain acceptable voltage profile and to minimize transmission loss. So to minimize the transmission loss, what are the changes that must be done in a power system, that will be studying in this unit 5, that is reactive power voltage control. So these are all about the topics that are being covered in this course. And also coming to the textbooks that you are suggested, that is Power System Analysis by John Greger and William Stevenson Jr. Also Modern Power System Analysis by D.B. Kothari and I.J. Nagarath, and also Electrical Power Systems by C.L. Wadhwa. So this is all about this lecture. From the next lecture onwards, we will be starting each one of the topics in detail one by one. Thank you.